Hello everyone, this is our tutorial video for the EEX281 Bank Project 3. So this is a new project as of fall 23, and the first thing I want to say is this video is made assuming that you've read through the spec at least somewhat. Now if you're feeling a little bit intimidated, don't worry, because the project is designed to be built in pieces. You don't have to understand everything at first, especially the place command, which is probably the most complicated, before you start coding. So you can start with the command line, which will be very similar to you from other projects. One thing you'll notice different about the command line here is that there will be a file name specified on the command line. So you might have something like ./bank -v if you've got verbose mode on, -f, and then we might have a file like spec-reg.txt, so that's the registration file. And then of course, as before, you could do like less than spec-commands. Whoops, why are you doing this to me? I don't know what it just did to that. Okay, anyway. So you'll do the redirection as normal, although we're going to specify file name on the command line with -f, and then the name of the registration file. So the registration file has the accounts that you have to keep track of. You can start reading that file first, would make sense, because until you're done reading the registration file, you can't process any commands about transferring money around or even logging in. When you read the registration file, I would suggest either read the entire line with getLine, and then you could use the string functions to break it into pieces. So the string functions have things like .find and .subster to allow you to break it into pieces. And so the other way to do it, there's another version of getLine where you give it the file stream, like let's call it reg file. And then the string that we're going to read it into, we can just call it str for now. And then there's a third parameter. You can say something like vertical bar. And what that says is, it says read up to, but not including, the vertical bar character. And so when you do that, it's like when you read to the end of the line, you don't get the \n as part of your input. Just like this, when you read with a vertical bar, it reads up to and gets rid of the vertical bar, but it's not part of your input. So you could get like the timestamp, and I said str here because I couldn't remember the order, I looked it up. So you could do like the timestamp, you could do another get line with the username, you could do another get line with their, I think the third one is their PIN number, and then you could do a fourth one with their balance. But this one you would want to do the parentheses and not the vertical bar, because there's no vertical bar at the end. So that's how you could get it in separate pieces. So you can do it either way, it's not a big deal. You either read the whole line and then break it into pieces, or read the line a piece at a time. But you can't use greater than here because there's no spaces. It would greater than with a string would read the entire line, and then we'd be back to breaking it into pieces. Okay, so then after you're happy with your registration file reading, and you could just print it to cout or cerr just to double check, or open up your debugger and look inside your data structure. After you're happy with that, then start reading the operations, starting with the commands, and those are going to be read from cin. Now there's one thing that I want to point out right now that's in the, oh no, I don't care that's full, go away. There's another thing I want to point out that's in the tip section. And it's in the tip section, it's down kind of near the bottom. It's a section called being partially done. And this is a good idea, basically, even if you've written every command, you should still do the second part. So the first part about being partially done is if you've got a command that you haven't finished yet, like maybe you've done login and out, but you haven't done the place command yet. If you recognize that you have a place command, do a get line and throw the rest of that line away so that the other stuff on the line doesn't trigger other weird conditions, like thinking that there's a command coming up that isn't. So do any incomplete command, do a get line, just get the whole line and throw it away. The other thing that's important to do when you're working on the project is inside of your loops that read from CN, and I say loops and it says that loops in there. It could be one loop, it could be two loops, one for the operations, one for queries, or you could have one big loop for the whole thing, doesn't matter which. But anyway, you want to do this thing that says if cn.fail, parentheses, parentheses, curly brace, and we'll do like a cerr, and then an exit one. And the reason to do that is if you make a mistake in what you're reading, it can put the CN into what's called a fail state. And like if you try to read a number and there's actually a like an A there, it'll put CN into a fail state and everything will fail. And then you could get basically nearly infinite output. We'll cut you off eventually, but you could waste a lot of time and a lot of disk space trying to produce this output, trying to understand something when nothing's being read from CN. So please do this in your loops that read the operations and the queries, or if there's one loop, you'll have one of these. If there's two loops, you're going to have two of these. But that'll make sure that you don't go into infinite loops with things that are partly done or that have slight mistakes in them. Okay, so then when we start working on the commands, so the commands I would start out with, and let's just say operations, because we're going to talk about those first. So the operations, the order I would suggest doing them in is number sign, which is the comment, then the triple dollar sign, which is sort of the end of operations and possibly the start of queries. There might not be queries, there might be queries, but there'll at least be a triple dollar sign. So every file is going to have a triple dollar sign. I think every file on the AutoGrader has a comment because we put at least one comment in ours to remind ourselves why we wrote the test case. So do those first, those will be pretty easy. And then do login, and then out, and then the place command. And that's a good order to do them in, because until someone's logged in, you can't verify that they should be able to do a place command. Out is a lot easier than place. And that's a decent order to do them in. One thing, when you're doing for the comment, don't assume that there's a space, because the comment could look like number sign, like this test. And if you read a string with greater than, and you say if the string is number sign, it's not, it's number sign this. And that brings me to the other thing I wanted to mention. When you're reading the commands, most of the commands should be read with a greater than to read a string. And every command is well formed in that once you read one thing, you know what's coming next. For the comment, once you know that it is a comment, then I would get line the rest of it. But when you're reading the CN, I wouldn't use get line for anything except comments. When you're starting to organize the project, it would be a good idea to make a bank class, and you're going to have some other data types inside of that, like a user, maybe a transaction, and those data structures will then be used for the place command, etc. So the user data structure could keep track of like where the user is logged in and what they've done. And as you add more commands, you'll discover that you need more pieces of data. When you're reading in the registration file and you've got those timestamps, or sorry, not the registration, the command file. So when you're reading the commands and you have times, oh, actually, they are in the registration file also. Yeah, that's right. Okay. So when you read a timestamp from the registration file, that's when the user's account was created. When you read a timestamp from the command file, that could be when the command is supposed to happen. It could be when it's supposed to take place with the place command with the execution date. One thing about those timestamps is there are things like, for example, what's in the spec test. We've got one like 08:01:01:01:34. Now, if you read it like this and store it like this, it takes up a fair bit of memory because all strings are 32 bytes. And if the string itself is 16 characters or longer, it takes the length of the string plus 1 per \0 plus the 32 for the string itself. And also, when you compare strings to say like, hey, is this user trying to give me a timestamp that's after they've been created? Because, you know, you can't transfer money before your account exists. So when you're doing comparisons on strings, they could be really slow. You know, if I was comparing this to 08:01:02:, blah, 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 I would have to say, well, is it empty? Is it empty? No. Okay. Is it 0? Is 0 equal to 0? Yes. Increment. Am I off the end? Am I off the end? No. Is 8 equal to 8? Yes. Increment. Am I off the end? No. Am I off the end? No. Is 0 equal to 0? Yes. Increment. Oh, wait, I forgot the colon. Past the colon. So you get the idea. It takes lots of operations to see if two strings are the same. It's like 5 operations per character until you find that it's different or greater than or equal to or whatever you're trying to do. So it would be really helpful if you read them. You have to read them with the colons, but if you then convert them to a number, the number will be like 8 bytes, and it takes 1 comparison on an 8-byte integer. So you're going to have to use, if you convert this into an integer, you'd have to use a uint 64_t. Because a uint 32t is not big enough for the number of digits here. We've got 12 digits, which is bigger than 4 billion, potentially. So we've got to convert it to a uint 64t, and when you do that, when you do the conversion and you make constants, you might have to say like, ooh, take this digit or this 2-digit number and multiply it by a certain amount to sort of move it. Stuff like that. You might want to do things like multiply by something like 100 ULL. So that stands for, so it basically says this constant is an unsigned long, which is basically equivalent to a uint 64t. For most compilers and operating systems, uint 64t and unsigned long mean the same thing. But that's the sort of suffix for the constant. If you put a ULL there, it means, hey, this is a long number. When you start multiplying this stuff, you've got to make sure to do it in that 64-bit format. So if you don't do that, you might have problems with converting depending on what order you do the operations in. We don't want you stuck on that. As you start doing things like, as you start reading the registration file, you'll have to keep some information for a user, like about the time when they were created, their name of the user, the PIN number for their account, and their balance. So you'll read all those in and have to store those. And as you start going through things like the place command, and then especially the queries, you'll start discovering that you have to add more information to a user. You might have to add more information to a transaction. You might even have to make new containers completely. And so if you have like a bank class and you make these member functions of the bank class and member variables, then you can add things to the bank. You can add things to your users, which you store somewhere. You can add things to transactions. So like when I ended up doing mine, I had like a bank class. I had a transaction struct, which could have been a class also, no big deal either way, a user struct or a user class. Just make sure if you make multiple classes for things like user and transaction, don't code them in a separate CPP file. They're going to get used by like bank.cpp a million times, and you don't want to be slow. If you want to know why it would be slow to code little one-line getters and setters in a separate CPP file, look at Canvas, Files, Optimization Tips, and search for the section about inline or inlining. I forget which word is in there the most. So that's why it's slow to code little functions that get called a million times in separate CPP files. Okay, so as you start implementing other commands like place and the queries, be willing to expand your data structures and perhaps create new data structures to deal with them. Now, one thing that is important I want to point out is something about the place command. So when you have the place command, we guarantee you that the place command timestamps will be non-decreasing. So for instance, I can have a place command, I can't type. So I could have a place command, let's do like 112233445566. And if there's another place command after that, we guarantee that it will not have a lower timestamp. It could be the same, it could be higher, but it won't be lower. So we could have something like 112233556677. That would be valid. Now, over at the end of here, there's what's called the execution date. And that's when the place command is supposed to be carried out. Now, this execution date can be up to 3 days in the future. The execution dates are not guaranteed to be non-decreasing, because I could say, hey, like I need to pay my cable bill, I need to pay my cable bill at an execution date of like 11223600, blah, blah. And then I could say, oh yeah, and I've got to pay the power company at 11223400, blah, blah. So these don't have to be non-decreasing. The timestamps will, we guarantee that, but the execution dates do not have to be. So you're going to have a data structure for the outstanding transactions, because you got to make sure the output comes in the right order. So you've got to have a data structure for the sort of pending transactions that will make sure that they come out in the right order. I wonder what we could use for that. So think about that. Also, with the place commands, one thing that you have to make sure of is that the output of the place command, the timestamps for the when they occur when a transaction occurs. So a place command will say, okay, maybe this has to happen right now, maybe it has to happen in the future, but you won't necessarily know that until you get a later one. So let's do an example. Let me just get rid of the word output here. Trying to think of the best way to do this. I think I got it. So let's say someone else does a place command, and this timestamp is 11223500, blah, blah, blah. You would say, at this timestamp, I've got to process any queries that or any transactions that should have happened before now, like this one. So when you see that place command, you would have to get this one out of the pending transactions, and you'd say, okay, if verbose mode is on, you'd say I executed this transaction, and then you would produce the output of the place command itself, which says, hey, I placed this one, I saw this place command happen. So with the place command, when it either executes a pending transaction or places a new one, those will all have to have non-decreasing timestamps. So we would see this one, the output of this one being executed would come before the output of, hey, this one was added to the pending transactions for the future. So you've got to make sure that the execution order is correct. And there's at least one test case that we created that has a hint. They'll say, like, if you're wrong at this line, double check when transactions get processed and when they're occurring. Okay, then the other thing that I want to mention is when you're working on the query commands, especially, you're going to be discovering that you need extra data. And the other thing that you have to remember, and I know I mentioned in lecture, is unordered maps and unordered sets are really cool. They are the answer to lots of interview questions, they're answers to lots of coding questions, but they're not the answer to everything. So when things happen in a certain order, and when things have to be done from like timestamp 1 to timestamp 2, if you need that sort of range of stuff in a query, sometimes having a sorted container and doing binary searching is perfectly valid and works very efficiently. Unordered maps are not the answer when you need something from one place to another, because they don't work with less than, they don't work with greater than. You might say, well, I could use a map instead, and that'll keep them in the order I want. That's true, but those are kind of a memory hog, because every piece of data, the map data structure is a balanced binary tree. Everything you put in it has got like a pointer before or a pointer to left child, pointer to right child, and so it could be. I haven't written it that way. I've done it with a different type of container than a map. It could go over memory if you use a map for that. I'm not sure. But if you do, you can always fix those lines of code. Don't feel like you have to be able to get 100% on your first submit. Be willing to learn from programming, not mistakes, but maybe just suboptimal decisions by changing a data structure, rewriting the code. The second time you write it will go a lot faster than the first time, because you know what you want to happen. You just have to make it happen in a different type of data structure. So be willing to do that. Okay, well, that's everything I've got notes for to talk about for the new project 3. So enjoy the project. Good luck with it, everyone, and we'll see you in office hours if you need help.